everyone. So in this video we're going to be proving the conditional variance theorem. So this theorem, how did this come about? Okay, so let's first write down the definition of a variance, okay, of a conditional variance. Definition of a conditional variance is it is the expectation of y. This is y given x, so we're going to have the expectation of y minus the expectation of y given x, everything whole squared given x. Okay, that's the by definition. Okay, so this is by definition. Now, let us continue expanding this. Let's expand the inside. Okay, so the inside, if we expand this part right here, we expand this part right there, we get y squared minus 2i expectation of y given x minus, okay, the expectation of y given x, everything squared given x. Now, because e is a linear operator, we can just treat e as a linear operator that we can multiply into. Okay, we can multiply into this expression. So what we can do is multiply it into the expression. We will have e. But remember to also write given x. Okay, so e y squared given x for our first term. Okay, and then minus e 2y y given x given x. Okay, that's the second term. The third term, that one, is going to be minus e given y x, everything is squared given x. Okay, now this looks complicated. So, well, let's just keep going, okay? So we'll just leave the first term as it is, because we can't really do anything. But the second term here, okay, so we have e 2y y given x. We can use the useful rule, right? So now, because this one right here, this e y given x is going to be a function of x. So let's just say that that's g of x, okay? And the same thing goes with this one right here. This is also a function of x right here. This whole thing squared is a function of x. A function of x squared is just a function of x. Now, we can take it out of the equation. Sorry, not the equation. We can take it out of the expression. Okay? By the useful rule. So we take this out. E y given x. Now what is left? Actually, I can also take this constant out too. So taking 2 and e y given x, what's going to be left inside the equation? Well, it's just e y given x minus e y given x whole squared. I'll just write it like that, okay? I hope it's not confusing. Well, let me actually just write it that way so that it's not confusing, because sometimes it gets confusing when you when you don't use an extra bracket. Okay, now what is left inside here? Nothing. 1. So e1 given x. Now we've got ey squared given x minus 2 times, well, we've got 2 ey given x here, so this is going to be ey given x whole squared like that. Now this, remember the expectation of a constant is just that constant, so 1. 1 is just 1. Okay, so because that thing is 1, we're just going to have this term as it is. Okay, like that. Now, we've got minus 2 ey given x whole squared minus my bad. Actually, we made a mistake here. This is supposed to be plus. Okay. All right, so minus 2 ey given x whole squared plus ey given x whole squared will just be, we're almost done here, minus ey given x whole squared. And that is this equation. So variance of y given x is equal to the expectation of y squared given x right here, expectation of y squared given x minus e, the expectation of y given x whole power 2, like everything power 2. So that is the proof for this theorem. Thank you.